Okay, it's just gone 2 o'clock. Good afternoon to everybody. Thank you very much for being here today for today's installment of the mini school by Dr. Ali Raza, titled From Notes to Articles, Writing with LaTeX and Mathpix. So thank you very much to Dr. Ali Raza for compiling this for us. This mini school is a recorded version. Dr. Raza is busy with a conference today and kindly recorded this session for us overnight so that this mini school could proceed today as scheduled in its time slot. So thank you very much for being here today. I think what we should do at the end, we can maybe just, I think what I could do is I can share Dr. Raza's email address with you. If you guys want to go into discussion or some questions, then you're most welcome to do so. So, okay, you are not here to listen to me, so let me hand over. Belinda, can I ask you if you can start the presentation? Let's see if the sound comes through okay, and then if there's anything else you can...
welcome to our second lecture of mini school organized by NITheCS, from lecture notes to article writing with LaTeX and Mathpix. So in our second lectures, we will discuss about the tools that will be helpful for writing our documents in LaTeX. And before going to discuss the new things and tools, let's have a quick revisions of the things we discussed in lecture 1. So we discussed some of the writing tools, online writing tools for collaborations, and plot-based LaTeX editor, which is the overleaf, and LaTeX is a software or a document preparation system for high quality typesetting. And the next main thing is Mathpix, which actually help us converting the mathematical equations into LaTeX for writing our documents or the tables or the other elements which can be used for writing a document. Okay, so then we discuss the offline LaTeX editors. The first one is the Text Maker, and the second one is the Text Studio. These are the open source free LaTeX editors, and we require a MITheCS, which is actually the text distributions we require to install in order to work on text editors. So MITheCS is the distributions for the Windows, mainly for Windows, but MacTeX is distributions for Mac operating system, and it can also be installed on Linux and for editing of offline or creating offline documents on LaTeX. So then we discuss the 5 standard document classes: report, writing, article, beamer, slides, letter, and book. And the LaTeX syntax are mentioned below each document class. And then in order to work offline, we have to install the MITheCS Works and the Text Maker as before starting editing your documents offline on your desktop computer. And then we discuss the how to create a basic documents using overleaf, and we have looked how to find a suitable template for your documents, either for your lecture notes, either for your slide, or for article writing, or for thesis writing, or for book writing. So you can find the template, and you can start with any template, and you can start writing your documents. But the first basic document is you can also start with the blank document or blank project, and then you can add your you can write your or create your LaTeX document, lecture notes or article or your thesis. So this is the basic LaTeX document. Consists of 3 main elements. The first element is the preamble, and the second is document information, and the third part of the document is main body of the document, where you actually write your documents. So preamble, you include all the packages, and the second component of the LaTeX document is the author informations or document informations, and then you have a main body of your documents. Okay, so here is the frames in Beamers. So for example, in Beamers, you create a frames to have your slides. So each slide or each page in your slide or presentations represents a frame. So you can create a frames in Beamer to create new slides. For example, currently the page you are currently the page or slide showing in your window is actually the frame, which is actually a slide. But in LaTeX language, it's a frame. So each Beamer project is made up of a series of frames. Each frame produces one or more slides depending on the overlays. And we discuss the alignment, center, top, and bottom. And then we discuss some of the packages, the essential packages for inserting pictures, for mathematical symbols, equations, and for adjusting margins and layout, and for defining color definitions or color text, we can use these packages. And then we have packages for document designs and utility packages. And then we have packages for the references and citation. And then we discuss the macros. We can define our own macros. And these are the important for writing the lemma or theorems or proofs in a most appropriate way. And here are the LaTeX for that. So let's listing documents have different types. So two of them consist of atomize and enumerate. So in atomize, you can write bullets, and for enumerates, you can show the lists with numbers. And we concluded actually our first lectures here, and then we had and we also practice the offline tools and the online tools or editors for creating our documents. So list in the list, actually the sub list, if you create a enumerate, so it will create a sub list. Even if you create a atomize, in atomize, it will create a sub list. And then we discuss the mathematical elements in LaTeX, which actually for mathematics, for mathematical expressions, we actually take the help of Mathpix. Okay, so this is actually the equation. So currently you can see three equations. The first equation is equal to mc square, and second equation is a square plus b square is equal to c square. And the third equation is a piecewise functions, which is actually we can define in cases. And on the left hand side, you can see the LaTeX syntax. We can begin with align, we can begin with equations. Let me just show you. So this is the this is the blank project I created on. So I created to show you how we can write equations, or for example, so this is the first thing you can create equations by writing the second LaTeX command. Begin with equations. So you can select the equation. So for example, if you want to include these pictures, we can use the Mathpix. For example, if you want to include two equations, so we will use the we will take the help from the Mathpix, and it will provide us the LaTeX code for these equations. So we can include that. We can write equations with the align. So if I need this code, so I will copy this code from here and paste it here and just recompile it. So it will show us the equations a square plus b square is equal to c square. Even we can write the equation, which is actually our first equation, is equal to mc square. Okay, so you can write your equations. So you can see the difference between these two. If you write your equations, it's a proper way to write equation in your LaTeX document. It will it will also automatically represents the equations with the numbering. And if you want to label your equations, you can label your equation with equation number 1, equation number 2, or equation number 3, and so on. And this is another way to write equations, which is aligned, and you can see the in the Mathpix, you can see the code from here, which is actually, so Mathpix can provide you the different variety of codes. It's on you which is suitable for you. So you can use different LaTeX command using the help of Mathpix, or maybe when you practice, you will learn the different ways of writing equations. Then you have to adopt which is the most suitable for you and which is the most convenient for you. Okay, so here is the explanation. So begin with alliance we use for multiple equations using the and symbol at align points. So you can see that one thing is important. Each equal sign in each equations is aligned actually, right? So for aligned, you can see in the equations in the LaTeX syntax, you can see and symbol before equal, and symbol before equal in the second line, and in the third line you can see the and symbol before equal. So you can use and symbol for the alignments. And then begin cases defines the piecewise functions with conditions aligned at commas, and it requires AMS math packages for mathematical formatting. So each component required packages in the preamble. So without packages, sometimes you can't execute or compile your documents. And these are the mathematical elements, matrix summations, and integral notations. For matrix, you can start with B matrix, which creates a matrix, and sum and integrals. Sum symbol you can use for example, let me just take the help of Mathpix and let me show you the code. So if you okay, so you can choose different variety of codes. For example, so I select one code out of 4. So this is showing me the output as a matrix. So these are the 4 options you can choose, and the confidence level is this represents the accuracy of the snipping tool. Okay, so the second and third element is the sum and the integral. So let me just use this. Let me just choose the third option, the double dollar sign. So you can also represent your equation with double dollar sign, and you can snip any mathematical equations or symbols or matrix or any mathematical elements using the help of Mathpix. So here is the code. So you can see using sum command, you can write your summation, and using using integral int command, you can write your integral. Okay, so similarly, you can represent interesting types of formats or features to make your documents looks good. Okay, so under base VEC command, head command, bar command. So you can use the head command for the cap, and bar command for the bar, and you can use math call F which cannot be Fourier transformation operator. So there are many types of operators. So for example, the real numbers we use mathcall or. So these are the mathematical operator you can use in LaTeX. So let's see, we can also take the help from the Mathpix to snip this okay. So you can see that so hat is for cap and math call is for your special character or for special character. This special character is used for the Fourier transformation. So okay, so we can see we can copy the code and paste here in the code editor, and you can see the exactly Mathpix is exactly converting the equations from writing to LaTeX code. Okay, so then you have other mathematical symbols as well, and the important thing here, which is important to mention here, is the sub equations and numbering. So you can write the sub equations. By using the command begin sub equations, and the numbering here you can see that is 2a, 2b, and 2c. So for sub equations, you can use the command sub equations, which groups the groups related equations with a shared main number and alphabetical sub-label. So for example, sometimes you need to write a set of equations. So for that set of equation, you can use sub-equation. Each line within a line is numbered automatically. For example, 1a, 2a, 2b, 2c. So this also requires the AMS math package, and you can reference them and you can using the label command and reference command. So for example, I label these equations. So how you can add the reference of the equation. For example, equation for reference, you have to use reference, and you label the equation number 1. So equation 1, just recompile it. So this is equation 2. So and then we can define different equations. We can label different equation, each equation by number 1, number 2, and number 3 to maintain the order. So now our equation 1 is actually equation 1, which represents the function. So equation 1 represents a function. Okay, so this is how you can reference your equation by adding label and by adding reference command. And this is how you can add reference and label. Okay, so this is the code. This is the complete code for writing sub equations to represent the corresponding numbering. Okay, so this is a code for adding pictures. With the syntax code start with begin figures, and then you can include pictures, and you can adjust the size and width of the pictures by changing the number. So currently here you can see that on your screen the width of the picture is 0.3. So you can change this number to adjust the width of a picture or size of the picture. And you can add the captions, Stellenbosch University logo. So this is how you can add your pictures. Okay, so and the next thing is you can add 2 pictures or more than 2 pictures according to your choice. And then here is a code for simple tables in LaTeX. So on the left-hand side, you can see the LaTeX syntax, and on the right-hand side, you can see the output. So begin with tabular. So you can so for the table, for creating table in your LaTeX document, you can use the command begin tabular, and which creates a which can create columns depending on your choice. For example, on the right hand side, in the first line up next to the tabular, you can see 3C. So these 3C represents 3 columns table, each centered at C with border. And H line, the second on the second line, H line actually insert the horizontal line, and columns are represented by and each row ends with double backslash. So the table ends with and tabular. So okay, so this is the LaTeX syntax you can see on your end. I will use the LaTeX. I will use the Mathpix to snip the LaTeX code from the table. So you can see we have 4 options now. So let me choose the third option. So now let's see, copy the code and just paste it here in the code editor and recompile it, and you will see exactly the same table with 3 columns A, B, C, and let's just compare in our slides. In our slide, we have this output, and we snip the LaTeX code using the Mathpix, and you can see we using the Mathpix, we created the code for this table in just few seconds. Okay, so then these are the advanced tables. So for advanced tables, the codes are different. For example, let's just try Mathpix. So will it be able to create exact code for, okay. So these are the limitation of Mathpix. So let me just okay, copy and paste it here, and let's just recompile it to check how this code works. Okay, so Mathpix actually can provide you the basic table actually. So in order to have advanced table or with special uh, features, or maybe, for example, these kinds of this is an advanced table where we use the color header, and we use different column widths, and well, it's this table actually includes more components, which is actually a nice table which can enhance the quality of your article or your documents. So one way to actually we can take the help from ChatGPT. We can say that improve this table code and represent this table in a interactive way. So this is how you can write the prompt to ask help from the ChatGPT to improve the code so that we can present our table in an interactive way and provide the improved LaTeX code. Okay, so we can take the help from ChatGPT, and let's see. So here, but see, the LaTeX code it provides contains all the elements. It's the document class, the preamble, and they define color and everything. So what we can do is we can just copy the table from here, or and let's just paste it here in our overlay documents. Okay, so if you paste the improved code, so it contains some errors. So why it contains some errors? So here's the thing we can check. So it defines some packages and defines some colors. So this is the reason uh, this is the reason we I think uh, reason of error. So we have to define the packages for table, for tabulars, for color tab, for and it defines also different colors. So let's just compile it by after adding the packages. So okay, so just provide us the uh, table code. Okay, so sometimes it has error. So, but sometimes code works, but sometimes it works. Sometimes it requires time, but you have to work with it in order to get. Okay, so let me just copy the code that I already okay created. So okay, so instead of using the code which contains error, I think we also required some. So here are some issues because we required some packages. So let me just copy the packages I defined here and let's just paste here. Okay. Okay, now, so the packages here, this is the first package I defined for table, and then the second one is for book tabs. So you now, okay, so without packages, if I recompile this document, you can see that it will not show you the output. So it looks like a error, and you you cannot differentiate either it's a table or it's a text or it's an equation because for each element you require a proper package for that. So let me just add the proper packages for table and then recompile the document again. And now you can see that this table is presented in a very nice and interactive way. So you have to work with packages in order to make your document beautiful and nice. Okay, so the next thing is the figures and the multi-line caption. So you can also define multi-captions by creating a tabular in your caption. So in this way, you can get the uh, you can define your captions multi captions. In the first line you can add the for example the title of the pictures, and in the second line you can define the descriptions of the pictures. So for multi line captions you will use the command tabular. So you can create two lines. The first line will represent the logo or the title of the picture, and the second line you can add the description. Okay, now so Detaxify. So this is a online tool. So for example, if you are writing a you're creating your documents and you are struggling with uh, writing a symbols, mathematical symbols. So even sometimes it's hard to find the symbols online. So let me, okay, just show you LaTeX math symbol. Okay, so if you are writing here you can find the list of mathematical symbols. So for example, let me just show you, here is the PDF which contains all the symbols. So I think all these symbols are listed here, where you can find the Greek letters, the math, LaTeX math constructions, and then standard function names, binary operations, arrow symbols, uh, math mode essence, array environment, or font sizes. There are different font sizes for equations or for text writing. And here, these are text mod symbols. But still, if you unable to find the symbol, uh, I think you will find you can uh, the symbol you are looking for. I think it should be here. If it is not here, then you can, for example, write this, draw the symbol here, and it will give you the option. So, for example, maybe you are looking for up xi, or maybe you are looking for up zeta. Okay, so this is the Detaxify online tool by using which you can find the symbols. And here you can find the LaTeX code. You can just copy the LaTeX code and you can add in your documents. Okay, so this is the Detaxify tools where you just draw the symbol and it will provide you some output and you can find the symbols. Okay, the next tool is actually image to text. For example, if you have an image where you want to convert your uh, image into text, so you can use this tool. So you can add the picture from here. So let me just take some picture. Okay, so if you take some picture and you will convert it, and in few seconds it will show you the results. So it will provide you the text from picture to the uh, if you if you're have if you have a picture which contain text, so this can convert the picture into text, and you can then simply copy the text and you can paste it. For example, here it's the original picture, and on the right hand side you have results. So this tool can provide you to the convert the picture into text. Okay, so then we have a Mathpix. So here is the formal overview of the Mathpix. So Mathpix is actually a snipping tool, just like snipping picture. So why we use Mathpix? So it instantly converts scanned or handwriting equations into LaTeX. So it recognizes printed, typed, or handwriting text. So what is the main thing actually? The main thing is actually by using Mathpix, it can save our time. So here is the link of the Mathpix. I will show you the detail, uh, each options of the Mathpix. Okay, so in a moment, but let's have a comparison of the uh, converting equations into LaTeX. So this is first equations where uh, at the bottom, you can see the confidence level, and it provides you the four options. So you can choose the option. The first option is without dollar sign, and the second option is actually with $1 sign, and the third option is actually with the double dollar sign, and the fourth option is actually the equation. So here are four different types of code. Uh, so you can choose according to your requirement. For example, if I want to choose first option, the first option, you can define the begin equations manually in your document, and then you can choose the first option. If you want to choose second option, if you want to add your text in a line, so in a line, you can so you use single dollar sign to add your mathematical equation in a line. So if you want to show your mathematical equations or expressions as an equation, so for that you use double dollar before the expression and after the expressions in order to represent your equations or expressions in a equation as the equation. So you can choose the option, one of the options out of four according to your choice. Okay, So it is showing you the confidence as well. Okay, let's see for this picture if it will be able to have uh, uh, converting this handwriting into LaTeX or not. Okay, so this is the Mathpix snipping tool. So using this Mathpix snipping tool, you can see the confidence level is low, but it converted most of the stuff into LaTeX. Okay, so in order to increase the accuracy, you can convert equations one by one in order to improve the accuracy. But if you convert the whole picture consists of more than 5-6 equations, then maybe the chances for error are more. We can see there are some mistakes in this conversion, but still it provides you the most of the stuff. Okay, so even if you are writing, you have to proofread at the end, but it takes lots of time. But using Mathpix, you can convert the handwriting. You can convert the handwriting consist of your mathematical equations or mathematical writing. So you can convert in no time from your notes into LaTeX writing. So this will save your time in order to while creating your documents. Okay, so let's have a let's discuss some of the prompts for uh, using ChatGPT in a better way. So use a Feynman techniques to learn faster. For example, if you are learning LaTeX, so you can say that explain LaTeX in a simplest term possible as if you are teaching it to a complete beginner. And the second most appropriate command for using ChatGPT or learning any topic is you can use the Pareto principle, which is help me learn about LaTeX, identify and share the 20% of learnings from the topic that will help me understand 80% of it. So you can use this principle to or this prompt using the Pareto's principles to learn any topic uh, using ChatGPT. So it will provide you, and then you can use this prompt to enhance your memory. For example, you can say that transform key concept or lessons from LaTeX into engaging stories or to help me better remember and understand it. So it will provide you the concept in terms of stories. And then there is a third last uh, prompt. You can ask ChatGPT to uh, create a mock interview to test your knowledge and close the gap. So it will provide you it will ask questions one by one uh, to test you to build your knowledge. So you command. Okay, so Mathpix snipping tool. This is the equation. So this is, for example, this is your writing. You are writing lecture, and this is the writing you want to convert into LaTeX. So using the Mathpix, after snipping, it provides me this code. But this code is not it's, the Mathpix did its job wonderfully. But the thing is, it's not a proper code for adding in your documents. What you can do is you can take the help from ChatGPT. So what you can do is you can just copy your this LaTeX code and you can ask ChatGPT to improve this code uh, in a best possible way. So on the right hand side, you can see the improved LaTeX code, and which is actually you can have a look at the matrix which are represented in a proper presentation. And on the right hand side, you can see the picture which is the LaTeX code. You just from your handwriting. So you can Mathpix can do its job, and then you can take the help from ChatGPT to improve this text based on the notation you used in your handwriting. Okay, so this is how you can use the Mathpix to snipping tools and ChatGPT to improve your text using the ChatGPT. But you can do it uh, uh, within staying in the academic ethics. Okay, so Mathpix is not free, allowed. But the thing is, it's not that expensive. You can divide into two or three. You can, for example, two or three friends can buy it, and you can divide the price into three equal pieces. Okay, so but if you don't want to purchase, it's fine. We have a free tool, which is a free tool which is Math. For example, let me just okay. Oh, okay. So this is the picture. Okay. So cool. So this is the software which is free if you look at the information of so an AI powered free alternative to Mathpix. Okay, so Mathpix actually this is a free tool alternative to Mathpix. So you can upload the picture here, consist of your equations, math equations or tables. So it will provide that corresponding to that picture. Consisting mathematical equations are simple, and then you can copy the so it is providing you only one option. But the thing is, Mathpix providing Mathpix provide you more options, right? According to a text including single dollar consist of equations, cent code or consist of double dollar. So the thing is, it provides more options, but that this is a free free software, so it is providing you only one option. Okay, so just have a look at the comparison between the Mathpix and Mathpix. So if you use this handwriting to convert the handwriting into LaTeX code using the Mathpix, so it's creating a pass now. So so it means Mathpix is better than Mathpix, but as it is free, we have to find a way in which we can use Mathpix in a better way. Okay, so instead of inserting or inserting the picture and converting into the LaTeX code, uh, in our instead of inserting the whole picture, what you can do is snip the picture into single equations. So if you insert single equations using the math team, and if you convert the single equation into LaTeX, it is it is working perfectly. So using the math team, if you do it equation by equation, then it will provide you the accurate code. And this is free website, and it can save your time if you don't want to spend money. You can use math cheap software to convert your mathematical equations into LaTeX. Okay, so the other tool is there is a difference between comparison between the NITheCS and Mathpix snipping tools, and then we have another tools for equation generator, uh, equation generating, and table generating. Okay, so this is a online tool which actually create equations. For example, if you want to write equals, okay, for example, so if you want to write equations, you can using this website, which is LaTeX editor dot Raza.com. You can use this website to convert your equation, and it is showing you the instant output. You can create your equation and you can copy the code and you can paste it here. Your document. If you so this is these are the tools you can learn step by step. For example, which symbol has which symbol has so it will show you the corresponding LaTeX code for each mathematical symbol. So this online tool is very helpful for uh, learning the LaTeX writing step by step from beginning to advanced level. Even you can okay, so for matrix you can generate a matrix of these types. For example, if you want to generate your matrix uh, for you just want to insert array, you can use this option. If you want to insert matrix in this notation, you can insert matrix in this notation, and then you can okay, so then you can complete the matrix by adding the information or elements of the matrix. So these are the this is the and then if you want to increase the size, you can increase the size as well. Okay, so these are the this is the online tool to learn LaTeX. So this actually is very helpful for learning LaTeX. Okay. Now there is another website which is also for equation editor. So you can also so you can find some more advanced simple for corresponding to integral, corresponding to product, corresponding to summation or intersection or union. You can, and here are more options for writing piecewise functions or for matrix. And so here you can find the more varieties of simple. So these are two online tools to find to write LaTeX code from your corresponding to your mathematical symbols. Okay, so next thing is in the first lecture I showed you the different faculties. For example, you can also draw a complete pictures, a complete mathematical pictures or diagram in your LaTeX. So these are the tools you can use to create diagram and you can use to create tables. So let's just have a look at how we can generate tables. So this is the one of the examples. You can write your table here, and this will provide you the corresponding LaTeX code for that. Okay, so this website and this tool is for here you can write your table, and then it will provide you the corresponding LaTeX code. So if you are not means if you so this tool is actually providing you the basic LaTeX code for writing the table in your LaTeX document. Okay, if you are not using ChatGPT, if you don't trust ChatGPT, so these are the tools which are free from any kind of AI. So you can use these tools to convert your table into LaTeX. You can convert your equations into LaTeX. You can convert your mathematical expressions into LaTeX, and you can convert your diagrams into LaTeX as well. Okay, so this is the tool which convert your diagram into LaTeX. So for example, you are creating a diagram here. So if you want to construct this diagram, and if you want to, so you can construct any type of diagram using the lines or other objects using circle. So you can every step you are drawing picture here, it is converting your picture into LaTeX. So then you can use this text code to generate your this diagram into LaTeX. So this is the one online software, Quiver. You can use this online tool to convert. First, you can draw your diagram, which you want to add in your document, and then by clicking here at the bottom, it will provide you the LaTeX code, and then you can add the LaTeX code in your LaTeX document, and it will be nice to add pictures, your desired pictures you want to include in your document. So these are the tools, and there is one more tool which is Mathpix, and this one is more powerful than the co-work. So this tool actually also helps you. This is more general tool, which is actually the most, I think, the proper one and the suitable one, where you can write your equations, and if you want to, if you are writing this equation, and if you want to a LaTeX code for that, copy from here, and you can paste in your document. For example, let's just okay, so let's just paste the code here. So it is showing you this picture. You can see this picture. You just copy the LaTeX from here. Even for example, if you want to add this picture in your, if you want to add this equation in your document, and then you can make changes to according to your. So okay, so this is so in this you have 4 elements: the table, matrix, 2 different kinds of matrix with 2 different types of brackets, and you can also write the piecewise function. Okay, so this is the picture now. So this picture has a LaTeX code, and you can copy this code and you can write it here. You can paste it here and just recompile it, and it will show you the nice. Okay, so now you can adjust accordingly. So, but it is working fine. So you can copy the code. Okay, so this is actually the examples or template of the code, right? But you can create your own document as well. For example, text pictures or diagram. So you can create your documents and you can set your okay. So now you can add the graphs. For example, these are the graphs. You can add the elements. For example, if you want to include this element, and then if you want to include this element, you can readjust it. And if you want to add these plots, contour plots, or for example, if you want to add these pictures, or maybe okay. So okay, this is a picture. So this is an example. For example, if you want a LaTeX code for this, you can just copy the code from here and you can paste here. So this tool is very helpful for creating diagrams. Okay, so now you can see that it's working perfectly. So you can create your diagram here, and you can copy the code from here, and you can just paste the code in your LaTeX document. So it's working perfectly. So these are all the tools by using which you can create your nice documents in LaTeX. Okay. So these are the tools. Okay. So before question answer session, I want to show you guys some of the lecture notes. So this is the first lecture notes I prepared on LaTeX. So here are the contents, algebraic properties of real number. These are the table of contents. And the notations I used for creating these documents are the following: subset is a member of, and these are all the notations. And each notations has a corresponding a particular LaTeX code. Without that LaTeX code, you can't write these symbols. And then here I use the atomize to write these bullets. Okay. The interesting thing is the diagram of this diagram of a real number real number line representation. So this is the real number line representations. I created these pictures using one of the tools I mentioned earlier. So here is a line, and then there are many components. You can see that there are numbers, for example, 0, 1, 2, 3, -1, -2, -3, -4, and then uh, uh, rational numbers, including radical symbols, and I presented using the lines. So this whole picture I created on one of the tools I mentioned earlier. So this is how you can create your uh, uh, documents. So this is the lecture notes. In the next lecture, I will show you component wise, means how we can what is the code for. So we will work properly. Everything we work on. So these everything we will practice using the LaTeX, and we will start from the basic element, and then we will practice the advanced element using the text pictures or equations or tables. So we will create a lecture notes using the Mathpix, and we will include all the elements, including list, including math equations, including tables, including pictures. Okay, so here is every picture here, every representation here. These are the algebraic properties of real number, and every property I explained with the help of graphical illustration, or using the graphical representation of real life. So I try to explain these algebraic properties or axioms. And then this is how you can write your theorem, and this is how you can define the proof of the theorem. And you can see the vertical line on the left side of the proof. So it is showing you the proof is starting from here, and the proof is ending at that line. So where the vertical line is ending. And then you can add the block for adding the definitions, and you can create your bullet points with the numbering or with the bullets. You can define your own enumerate and atomize as well. So here you can see the Roman numbers and then the bullets, and now here you can see the numbering 1, 2, and 3. And here 3 theorems, and next to 3 theorems I define. So I define the code for proof. So the proof of the uh, first statement is presented in the first line, and the proof of the second statement B is presented in the second line, and the proof of the third statement is presented at the third line. And you can see the blue line which representing the start of the proof and ending of the proof. Okay, so these are, and here you can define your code for adding example or adding for the proof or for the example. You can define these interactive uh, environment or typesetting. Okay, so you can see that you can include all the definitions and all the theorems, and you can use the text pictures code to represent all the diagrams which help you to explain in a better way. Okay, so at the end of the lecture notes, you can add some of the practice questions as well. So these are the elements of the lecture notes, and using the LaTeX, you can create some nice lecture notes as well. Okay, so this is the second lecture. This is second lecture, and the real number, and here you can see the second diagram. This is also created on the LaTeX using the text pictures package, and here another representations to include definitions, theorems, and every proof. And here you can define the environment for corollary, and this picture is also generated on LaTeX, and you can see the arrangement of the elements. For example, example A, example B, and there is solution. Okay, so here we have some more practice questions, and this topic epsilon, this section include the informations of the epsilon neighborhood and the definition of epsilon neighborhood, and you can see the pictures and the representations, and then the concept of epsilon neighborhood of A or more than one epsilon, and you can see the corresponding examples and the proof of the theorem. And then you can see the another example and its representation with the help of diagram, which is created on text picture. Okay, so yeah, so you can have a look at the notes. So every picture in this code is created on LaTeX. So this is how you can prepare your notes, and you can add all the elements using the LaTeX code. Okay, so one last thing I want to mention here, you can log in to your Mathpix website. So you can you can use the Mathpix on the web app as well. So you can once you log in, you will see these 4 boxes. So the first thing is the snip web app, and the second thing is the snipping tool for the desktop. You can download the desktop app, which I'm using, which is very easier to convert LaTeX to mathematical objects equations or table into LaTeX. Okay, so here is the Mathpix Snip web app. So on web app, you have these three options. You can convert the whole PDF document into your into. So okay, so for example, I have this document, which is actually a one page, which is one page text including text and mathematical equations. But this one is the basic one. Okay, let's just convert this page into LaTeX. So just click on the PDF icon here, and you can choose the file from your computer you want to convert it to LaTeX. So now in just few seconds, you can convert your whole PDF into LaTeX notes. So convert into note, so it will convert the PDF into notes where you can find all the so look at the original document. For example, the original document is okay. So just so the original document is okay. This is the original document. Okay, and this is the and this is the now let's do the comparison. So the notes PDF okay, so but you can see that this is the original document, and this is the document you convert it into LaTeX using the Mathpix. So it's almost I think most of the things are correct. So you can proofread even if you are writing the by hand manually. You have to proofread. So, but you have to proofread every time. But what what Mathpix is doing actually, it is saving your time for writing the whole documents into LaTeX. So using the Mathpix, you can convert the whole document into LaTeX text using the using these options. So okay, so now this is the lecture, which is not the simple document. So it contains many complex element as well: pictures, diagrams, theorems, environment. So let's have a look at how Mathpix can effectively convert the lecture notes into LaTeX. Okay, so this is taking time. So now let's convert into, okay, so it takes just few seconds actually. It's a whole lecture and it converts, but what it can do is it can provide you the basic environment. It is not converting the special characters or color combinations. These are the limitations of Mathpix, but it can provide you the basic text. Okay, so you can see that it converted the text pictures into actual pictures. So here you can't edit the pictures, but it converted the file into LaTeX LaTeX code, but some of the elements uh, are not converted properly because in the PDF I created these diagrams using the text pictures, but here you can see we have only the pictures. So these are the limitations of Mathpix, but still it is very effective. Thank you very much. You have any question, you can ask.
If you have any question, you can ask. You can raise your hand. Okay, so I guess there is no question. So in the next lectures, we will learn how to create and prepare a complete lecture notes, and we will discuss all the elements for preparing the lectures in the next lectures. Thank you so much.